welcome friends to this NPTEL MOOC schedule or course on handling large scale data using Stata. We are at the at the particular lecture of understanding binary response models. In the last lecture we already started discussing about Logit in a model and their theory, the basic premises behind the Logit as against the linear probability model, where OLS has been contradicted by the Logit. We are going to validate further also in this particular lecture. So, today we will emphasize further some other features of Logit, particularly from the last class. If you remember correctly, that it was the equation we are emphasizing on the log of odd ratio. Okay, that's particularly defining a linear equation in terms of the expected coefficients. So, that we mentioned. Now we are adding some attributes to the Logit model. Now, even I said earlier that when the probability in the diagram I told you already, it's sigmoid curve. Logit function follows a sigmoid graph, where the probabilities value varies from 0 to 1, with the z values varies from -infinity to infinity. So, the Logit that is L goes from -infinity to infinity, and though the probabilities lie between 0 to 1, the Logits are not so bounded. Okay. So, Logit value in the Stata also we are not going to get any bounded values. We should not be just confused by their coefficients. Okay. That why it is so, why it is not so. So, we will get to know it for sure. Whereas the LPM assumes that the probabilities are linearly related to x, the Logit model assumes that the log of odds are actually linearly related to x. The probabilities themselves are not necessarily linear. Okay. We can include as many as regressors when so required for the model. So, the L that stands for Logit is positive, means that when the value of the regressor or the regressors increases or regressor increases, the odds of that regression equals 1, indicate equals 1, meaning some event of interest happens also increases. Okay. If L the Logit is negative, the odd of that regression equals 1 decreases, okay, as the value of x increases. Okay. So, we are going to also present that odd ratio in terms of comparing with the unit value. If it is exceeding unit value, then it indicates a positive signal. That means the regressor impact the likelihood of the dependent variable positively. If the odd ratio is less than 1, then it is negatively impacting. We are going to emphasize this with the help of our data. Now, because the Logit and probit models and its linear estimation, that is OLS, are not applicable. So, the estimation of the Logit model is different. Okay. And since the model itself is not linear, so OLS is not applicable in this case. As if y is equal to 1, then the 1 the probability with 1 or 0 the odd ratio, and if it is 0, then the odd ratio is 0 by 1, are both meaningless. Okay. In this situation, we have to resort to the maximum likelihood. Okay. It is not just the probability with 1 and 0, rather the closeness to 1 or closeness to 0, that is identified through the maximum likelihood estimator, is actually more important, okay, than just the probabilities. So, the ML estimate of beta is the particular factor, that is beta hat ML, that gives the greatest likelihood of observing the sample of y1, y2 till yn, conditional upon the explanatory variable x. Now, when we say the unit change within the probability limit of 0 1 is very important, and the maximum likelihood estimator identifies that. So, the coefficient itself is not just enough. Okay. The absolute coefficient which is catering to probability of success or failure, or odd of success or not success is not enough. Rather, in that case the unit change value or the maximum likelihood estimator of its unit change expressed through marginal effects is very important. Okay. So, since the dependent variable is with 1 and 0, it is binary. So, the unit change, the very fractional change and its interpretation is very relevant. Okay. So, that is the reason why we are sticking to marginal effects. In linear regression model, the slope coefficient measures the change, okay, or the average value of the regression for a unit change in the value of the regressor. The actual coefficient in a logit or probability analysis are actually limited because of their immediate interpretability. The signs are meaningful, but the magnitude may not be. Magnitude, the coefficient is not actually meaningful, particularly when the variables are in different matrices. We cannot interpret the coefficients directly in terms of units of change in y with the unit change in x in the regression analysis. Rather, the coefficient of the logit function is quite difficult to interpret, since it follows a logistic distribution function. Okay. It is not a continuous series. There are fractional change in the probabilistic structure with the change in the z values from minus infinity to infinity. So, as a result of this, we compute the odds ratio and also the marginal effects. Marginal effects gives the derivative. Basically, when we say marginal, that means we have to take the derivative of the dependent with respect to the derivative of the independent. So, in the independent we have x as the set of or vector of independent variables or the regressors. So, if you take the derivative, partial derivative, because we have so many independent variables, if you take partial derivative with respect to x here, with respect to x here, then in that case it is important to find out. Okay. So, it is important to look at how partial it is, and with the unit change in this. So, let me just fix the pen here, whether it is coming. Okay, it was there earlier. Let me just check. I hope it has not been set. Okay, it is probably here too. All right, it is the pen mode. Okay, so touch is active. All right, so I will operate through this. That here I am now discussing about the partial derivative of the dependent variable with respect to the independent variable. Now, when we take the partial derivative, it will be certainly of the dy by dx of in the right hand side. You look at this carefully, dy by dx, which is dy is nothing but the cumulative distribution function, logistic distribution function with this. Okay. And when we take it, since x is here, okay, and this is a constant, all right. So, the derivative will be of others are constant. So, beta 1 hat is left, okay, that will be simply multiplied. Now, after that, what is that function of that logistic? We have already mentioned that beta hat plus beta 1 x is nothing but in the logistic function this is separated, and we are left with so the function is e to the power, this is e to the power minus z. So, e to the power minus z 1 upon e to the power minus z. So, 1 upon e to the power minus z. So, what we will do, if you take the derivative, it will be like here. Okay. So, this will be this will be if I just take the derivative, it will be in the denominator, it will be, if it is a it is in terms of ratio, the numerator the denominator will be of simply a square of it, in the first order derivative will be square of it. Then basically that is of okay, that is of in terms of square is there in the denominator, and in the numerator it is simply e to the power minus z, okay, e to the power minus z, and 1 plus this term, this is of square, okay. So, this is what we have derived. Now, the derivative is in fact non-linear and depends on the value of x. So, what is the meaning of it? That means the marginal effect or the impact of this we wanted to find out is actually whatever the marginal effect of y is actually observed through the x. So, z here we already defined in the last class that it is dependent upon x. Okay. Now, coming to the example, the real life example of testing the Logit function, the logistic estimation. There are some slight difference between logistic and Logit because of the ratio or the coefficient we are going to estimate, that we are mentioning in a short while. Now, the example we are going to cite is through our data, that is we are providing the sample data to you from the 7th NSS data. So, we have mentioned the title of the data as BCM binary choice model for practice, and the same variables we are linking with the LPM as well as for other Logit and Probit, we are going to compare. So, running the same model, what factors explain the choices of women being a necessity entrepreneur, that we already started discussing in the LPM. Now, we are again discussing with the Logit function as well. Okay. So, the choice whether which factor actually explain the choice of women being a necessity entrepreneur. So, that is what we are going to mention. So, we are not summarizing or describing the data as we have already done it in the previous lecture, and we have seen broadly that the data consist of bytes not in string. Okay. So, in numeric numbers. So, it is composed of categorical and non-categorical as well, in continuous series as well, but the dependent variable is in binary, and that we have already seen it. So, straight away we are going to run the model. Okay. So, once we use the model in the Stata, so let me open the Stata for you quickly, then we will go to now I am going to open the state BCM data. So, it is here okay. So, I am just going to open the data, BCM practice data. I told you already, now this has already been opened in this on the screen. Now, from the data we will now first operate the simple Logit function, okay, the Logit model. So, that Logit model we will estimate quickly. So, it is here. Now, let me operate all the variables that has been listed, and we are running it. Okay. So, once I run all those variables with Logit Logit Enterprise, now this this gives result very quickly. Now, the Logit function has generated the values in front of us, the coefficient values in front of us, with, as we already mentioned about R square and regarding pseudo R-squared, the coefficient have already been highlighted. The chi-square value, whether that is significant or not, even earlier models we did mention, now once again it is significantly defined. So, now most importantly the likelihood function, as I mentioned, this has taken 5 iteration. It kept on iterating all its variable with different forms of samples within the model, okay, by observing whether how they are actually varying. At the end it has iterated with a likelihood value of -2106, okay, but this is important to note here whether the model is fit or not, model is fine or not, whether we go with the model, because the probability of that the significance level of that chi-square value is 0.0000. So, it is not going to be problematic. Okay, now, it rests on which variable are important and how we are going to interpret. Now, from the model itself, now coefficients are given. Now, I have said in the features itself that in Logit model, even in probit also, the coefficient is not important, the odd ratio is important and the marginal effect is very important. Okay. So, we are going to discuss that right now. So, after doing so, as you can see very clearly that some of the variables are categorical, okay, and some of the variables are dummy. Okay. So, dummy variables we already defined in our previous lectures. Now, for that dummy, if you simply take dummy as an average without having any specification of the dummy, then average of dummy you will not have any correct interpretation. So, for that you have to take a base value, okay, in the dummy, like for to identify the base value we have gone through a command that is this, okay, I dot, all right. So, I dot before some variable denotes that these variables are dummy or categorical, that it should be included in the model as a series of indicator variables, okay, series of indicator variables. So, this I dot syntax was introduced in Stata 11, all right, 11 onwards this has been introduced. Now, those who have earlier version you might be in trouble. So, you have to take help command for further patching of any extra version of it or extra updated solution to it. Now, we can use xi also xi from the very beginning, that conditioning for the model with this categorical variable. So, like prefixing xi logit which gives exact the same result, but the coefficients are reported slightly different and the names corresponding directly to a newly generated dummy or indicator variable in the data set. Okay. So, we will just show it like if we just go by this command xi command, we can go for it, that we can show it here also in the Stata directly, okay, with the same command it is there. Just xi colon, if you add xi colon, you will get the interpret, I mean the look is different, okay. Now, it is in capital, you can make it in small. So, the capital entry, as we already mentioned that Stata is very case sensitive. So, you have to take small letters. Okay. Now, look at the coefficients here are interpreted against the exact non-reference category, but in the previous case you just see look at this, it is the reference category the value is also mentioned or not. Okay, let me see only okay. So, even I dot command we have taken. Okay. Now, against in the sector rural and urban. So, urban value is presented. Okay. Now, look at this. Okay. In the mixed activity also only 3 are presented. Now, here only 1, okay. Each against each, where is it? In the sector, sector only the category 2, that category itself is mentioned, it is nowhere mentioning the base category, is not it? So, so that is the only difference. Suppose you want to get small table, I think this is more useful, all right. So, these are also generated as well and defining the other categories as against to the base. Now, let's go by the detailing here. Now, coming to the interpretation further, this prefix was earlier used and it still works, but if you do not want to create new indicator variable, basically in the variables itself, it identifies the indicator variables, okay, which are the indicator variables, and these are added in the data set itself. Okay. But in the earlier case, it is not showing the indicator variable or not added at all. If you do not specify Stata which category to take as reference, by default it takes the first category category as the reference category. Okay. But there are techniques, if we add it, it gives the particular category as the base category. Like in rural urban, by default rural was 1 for us, 2 for urban. So, 1 considers as the base category by default. If you specify IB2 dot IB2, that means it specifies the second one as the base. Okay. So, now if you want to change the reference category, you can accordingly specify, or rest of the details are the same. Now, we are going to discuss also on we have already discussed about the maximizing the log likelihood function. So, 5 iterations we already discussed, and some other interpretation we already shown to you. Okay. So, in the result, that we can see that the iteration of log likelihood indicating how quickly the model converged. Okay. The log likelihood is used to compare the nested models. If you have any other nested models, that those likelihood estimator could also be useful for comparison. The likelihood ratio with chi-square value we have already shown you, chi-square value of 189.65 with a p value that is 000, the significant, it indicates significant at 1% level. Okay. Explain that our model as a whole fits significantly better than a model with no predictors. Okay. So, like other regression model, the Logit regression also displays coefficients. Okay. So, coefficients that I mentioned, they are standard errors also, standard error next to their standard next to their coefficient, standard error are there. Okay. Then the Z statistics also, Z statistics, then the probability limit, the p values, we based on that we can find out whether which variable is significant. Okay. Like in urban, it is significant at 1% level. These two are not significant. Okay. These two are not significant. First two are not significant. Then sector urban is significant. In the mixed activities also, the middle one that is problem faced is significant. Okay. Similarly, you can interpret other coefficients. The confidence interval values are also defined. Now, coming to the interpretation of R-square in the model, and specifically we clarified in our previous lecture about pseudo R-square. Okay. Again, I am emphasizing on the pseudo R-square, that it is not similar to the R-square values we used to have in the continuous case or in the regression model, normal or ordinary least square method. But this pseudo R-square is analogous to the R-square we studied. This expresses the predictive quality of the model with explanatory variables relative to the predictive quality of the sample proportion of cases where y is equal to the success, and that is 1. So, pseudo R-square in this case using the likelihood ratio basically takes the log likelihood ratio and with unadjusted or unrestricted and the restricted model. In this case LUR, so the pseudo R-square is equal to 1 minus log of likelihood with unrestricted and log of restricted, in the numerator it is unrestricted. So, is the value of LUR is the value of log likelihood at the ML estimates, that is unrestricted model, and the log restricted or R is the log likelihood value of a restricted model in which the only explanatory variable is a constant. Okay. So, that is important, you can take a note of it. So, Stata computes, we already mentioned the McFadden technique of estimating R square, that is also called pseudo R square. In this case Stata adopts in this kind of models. Okay. Now, it should be emphasized that in binary regression models, goodness of fit measures are of secondary importance. Okay, what matters are the expected sign. The sign, the relationship is more important. Sign of the coefficient is more important. Okay, and their statistical or practical significance, with which we already discussed, is more important than that of R square. Okay, so if R square value is low, you may not worry, especially in these kind of models. Coming to the interpretation of coefficient further, among sectors as compared to rural, women entrepreneurs in urban sector decreases the log of odds of choosing necessity entrepreneurs by 0.262. Okay, so like we have already said here. All right, here it is 0. In this case, okay, the log of odds is of it is negatively related to the necessity entrepreneurs. So that means the enterprise or the women entrepreneurs to be necessity entrepreneurs being in urban area is negatively linked with a coefficient of coefficient of 0.263 roughly. Okay. Now similarly, the coefficient of the Logit function is quite difficult to interpret since it follows a logistic distribution function. Okay, so the coefficient which we have said, it's somewhere linking to average. Okay, average coefficient is actually not suggested to be interpreted. Since the function is logistic, it has to be in favor towards success or failure, or probabilistic structures is attached. So, or likelihood of estimation is attached. So, we should not interpret the coefficient as such, rather we should interpret, it is suggested to interpret the odds ratio and the marginal effect. Okay. So, Stata does this task by specifying simple command logistic instead of just logit. Okay. And okay, so the command is here, we can just operate. Now, basically whatever we operated, it is more or less same, okay, more or less same, but it gives only odd ratio. Okay, so odd ratio or logistic command, if you simply add here, that's give but if you have only logit till this, if you do not add this, it is not going to give odd ratio at all, it only gives coefficient. Okay. But if you simply comma add with OR stands for odd ratio, this certainly boils down to the odd ratio of it. Now, the results are like this, the way we have shown earlier, but I think this is more or less repetitive, you should not operate much, you can operate on your own. Okay. Now, the interpretation is like earlier we have seen coefficients, but now it is not coefficient. Now, the command here is in logistic. Okay, logistic. Now, more importantly, you have to check this first. Okay, then this is not that important, you may not be worried much about this pseudo R-square, but still here it seems 34% fitting to the model, it's a good fitting. Okay. Then coming to the interpretation of the coefficient. Now, wherever it is exceeding 1, okay, exceeding 1, that means those variables are positively linked to the dependent variable or the regression, and those who are less than 1, 1 we are taking a stand for probability of success. Okay. And so whichever are less, they are actually negative related, whichever are less than 1, they are negative related to the regression. Okay. So, like here these variables this variable we have already seen that was of minus of 2.262, but here now look at this is negatively linked, because as I told you, since these are in odd ratio, the probability of probability in favor of success or failure, and this is saying that being urban, a women entrepreneur is having a likelihood of minus, I mean negatively linked to being a necessity entrepreneur. Okay. So, likelihood of the women to be a necessity entrepreneur is negative. So, the interpretation exactly is that it is 0.7 times less likely to choose or to be a necessity entrepreneur. Okay. So, being in urban area. alright. Similarly, you can interpret other variables, okay, whichever it is more than one, that is it is positively, and otherwise it is negatively linked. So, marginal effect is very important. I suggest many times that coefficients are not to be interpreted, better to avoid that. So, straightway come to the interpretation of marginal effect. Okay. This provides a good approximation to the amount of change in y given the unit change in x. We have already defined its derivative. Okay. So, derivative values of y with respect to x, that the marginal effect depends upon the change in x. So, therefore, it is important. Now, the ME, that is marginal effect for categorical variable, shows that how the p with value 1 changes as the categorical variable changes from 0 to 1 after controlling in some way or the other variables in the model. In Stata, marginal effects can be computed using the MFX or the margin commands. Okay. So, you can take the help search MFX command from the Stata. So many suggestions will be there. Okay, you can get it. Out of that, we are going to operate with any of the command. We are going to operate with the margins command. Okay. So, this gives even the since we have taken dy by dx. So, somewhere we are linking to the elasticity of their estimation. Okay. So, in margin command also helps in giving the predicted probabilities. Okay. According to Stata manual, margins are statistics calculated from predictions of a previously fit model at fixed values of some covariates and averaging or otherwise integrating over the remaining variables. Basically, it is calculated from the predictions of the fitted variables, okay, or values. The capabilities include, I mean the capabilities of the marginal effect include estimated marginal means, like it estimated at means values, then least square means also, alright, average, then conditional marginal, partial effects. There are so many way of interpretation of the marginal values. So, which may be also reported as derivatives or elasticities. Average and conditional adjusted predictions and predictive margins. There are so many ways of interpreting the MEs. Okay. So, this was introduced, as I mentioned, since Stata 11 version. After running the Logit, once we run the Logit model, okay, then we can go for margins at means. Okay, one of the way of interpreting the ME. So, at means option actually estimates the margins at the mean of the covariate, that we just wanted to show you. Alright, so it is here. So, we simply get that to the model, to the Stata, since we have already derived the result. Now, we simply take at means value. Okay, so, margin at means, then we go to the Stata window. Then since Stata has already we run the Logit regression. Now, this has given the result. Now, at the means, the margin at its average mean or the average value or means is derived. Okay, so, I am going to discuss it. So, 0.89 is very important, and also that predicted values of each of these entries are also equally important for our interpretation. Okay, likewise this is what we derived. Now, here the probability of the enterprise with code 1, okay, that is necessity enterprise, is of 89, which we have shown, that is 89%, given that all the predictors are set to their mean values. All the predictors, it is highlighted here, variables at mean values. Okay, you can just have a check variables at mean values, and everywhere mean is mentioned. Okay. So, when all the variables are set as its mean, what is the probability of enterprise to be of necessity type, that is of 89, nearly 90%, nearly 90% is having a probability of to be necessity driven, okay, or necessity enterprises. Now, coming to specific command emphasizing sector and their margin, okay, particular sector wise, which sector has higher probability, rural or urban. Okay. If you specify with margins, margin, then margin with a sector, Okay, margin with a sector at means. Okay, initially we said only margins at means, that gives the total model, is not it. Now, when we specify to a particular categorical variable, we just wanted to know difference between rural and urban probabilities. Now, it has given the value, the result we can easily get with the same command if you can try. Now, for the rural and urban, rural it has given 90.902767. So, that means 90% probability there with the rural entrepreneur to be necessity driven or necessity type of enterprises, whereas in the urban it is of 87. So, even it is understood and logical that in urban areas the necessity enterprises are I mean likelihood of the enterprises to be necessity driven is very it should be less than that of the rural areas, because of many other problems or facilities, okay, or shortage of access, especially financial access as well, transport and financial access as well. Okay. So, now coming to the understanding relating to the margin command, this does not accept continuous variable, okay, that is more important, because we are comparing with categories. Okay. So, this actually does not accept the continuous variable as a factor variable, such as age or age squared is not going to be interpreted at all, or is not going to consider. Okay. It requires certain values of this variable at which it will calculate the margin. Okay. It will compare from one to another one. There must be some discrete difference, okay, from one category to another category, then only the margin could be derived, then only a derivative could be derived. Okay. So, now let us come to the understanding of the change in the probability. Okay. Some what are the change in the probability when the predictor or the independent variable increases by 1 unit. So, if there is there we simply say the absolute probability of a particular category when we keep others variables to be at their average, okay, value. Now, we are saying what is their marginal change actually, okay, a unit change. In that case, you have to take the dy by dx. Okay. So, dy by dx if you can take it, that will be giving a result like this. Okay. We can find it out also. So, let us have a check. So, dy by dx, and this is going to be more useful throughout your papers while you write for assignment or papers, it will be very useful. Okay. Now, this has given the marginal effect actually, which have been we are trying to interpret against each variable, each predictor variable. We have now derived its marginal effect, the unit change, the derivative of it, okay, the individual derivative of each variable on the dependent variable. So, the marginal change is highlighted, and these coefficients should be actually interpreted. Okay. Now, okay, those who are positive or negative very clearly understood. Generally, it is highly linked with the coefficient values, but the coefficient values if you interpret, that is misleading. Okay. So, better to stick to this. Now, dy by dx estimate average marginal effect of variables in the because we have set it at mean values. Okay. So, average marginal effect is derived. If we want conditional marginal effect for all covariates, we have to specify with a star or all with dy by dx, okay, underscore all with dy by dx both mean the same thing. Actually both I mean either this or this actually refer to the same interpretation. Okay. So, if you simply go by this, that will actually give you the conditional marginal effects. The I mean at means option gives result of conditional marginal effect, condition at the means of the variable. Okay. That is actually the conditional aspect we are referring to. Okay. Then we have to specify it. Now, in this case the change in the probability of one instant change in age, particularly age here, age is basically minus of 0.0003. So, the percentage the change in percentage it is of okay 0.02, all right. So age is here, the first one is a, second one is a squared. So in the second one case is a squared, that is of here it is 0.003. Okay, the first one is 0.01882, so roughly around 0.02 point. Okay. So coming to the discussion of urban area as against to the rural. Now in this case urban, it is negatively linked to the necessity entrepreneur. Now in percentage point it is of 2.5% lesser, okay, points. So I mean being from urban area decreases the probability of necessity entrepreneur by 2.5% and is highly statistically significant, that we wanted to check that. Okay. So this is statistically significant. Okay. Similarly, you can understand this is statistically significant, even these are statistically significant at different levels. Okay. Then these variable, this is, I am just mentioning, you can understand all three, all. Okay. Similarly, other you can compare. Alright. So, from the next class we will try to understand probit and tobit. Okay. So, I think it is very clearly understood to you that how Logit is operated and how marginal effect at conditional mean is understood, and it is important for interpretation. And please go and practice with any other data set, but sticking to the kind of specification with the dependent variable in independent variable, then that really works better. Okay. So, let us explore probit regression model from the next class. Thank you so much.